Here we have section 7.0, angle and radian measure. This actually isn't out of chapter 7, it's out of a previous chapter, but to do the upcoming stuff, we need to go back and cover this stuff, but it's the only section, so it gets to be 7.0. So angles and radian measure. So your objectives there, change from radian measure to degree measure and vice versa, find the length of an arc, and then find the area of a sector. So a radian is just another way to measure your angles. Previously, if you were having problems with your calculator giving you the wrong answer, it was because your calculator was in radians and not in degrees. But here's about the equivalence. So 1 radian is 180 divided by pi degrees. It works out to be about 57-ish degrees. Or the way 1 degree is pi divided by 180, so about 0.017 radians. So a radian is much larger than a degree. 1 radian is almost 60 degrees. So it's really easy to convert between the two because these are kind of the conversion factors. So to convert from radians to degrees, you're going to take your angle times 180 and divide it by pi. To go the other way, to go from degrees to radians, you're going to take your angle times pi over 180. When you do this, you leave your answer in terms of pi, so it'll be a fraction with a pi value. So pretty much you need to multiply by 1 over 180 and then add a pi to the end of it. So here's a couple examples. So the first one, change 330 degrees to radian measure in terms of pi. So to convert, take your angle, multiply by pi over 180. So what I'm actually going to do is do 330 over 180 and then multiply that by pi. So I'll do my calculator. 330 over 180 is 11 over 6. And then you put the pi on the top. Now you'll need to, if you get a decimal, convert to a fractions. So on the TIs, that's the math menu, and like the very first choice should be arrow frac, enter. If you've got a Casio, there's a key that says F arrow D, that'll convert you to a fraction. So to go the other way, you take your angle, multiply by 180 over pi. So now in this case, actually the pi's will cancel each other. So what you actually have is 2/3 times 180. So 2/3 times 180 is 120 degrees. So relatively straightforward. To convert 2 radians, pi is on top. To convert to degrees, pi is on the bottom. All right. If you know the radian measure of an angle, you can find the length of a circular arc. That's this distance along the edge, assuming you know the radius and the angle theta that make up that thing. So the length of the arc, S, is equal to the radius times the arc. So if you're given a central angle of 128 degrees, find the length of its intercepted arc in the circle of radius 5 centimeters, round to the nearest tenth. So R, or S, equals R theta. R in this case is 5 centimeters. Theta is 128 degrees, but we need to convert that to radians. So 128 times pi over 180. Now, since it says round to the nearest tenth, that means we can actually round this answer. So 128 divided by 180 times pi, this is about 2.2 radians. So S is equal to the radius, 5, times 2.2. So it's approximately 11 centimeters. All right. A sector is the area that's bounded. So if you have your circle, R's, there's theta, this area, that's the sector, the shaded part there. So once again, if theta is the measure of the central angle in radians, and R is the measure of the radius, that should be area of the sector A is as follows: 1/2 pi R squared theta. So here's our example. Find the another area of a sector if the central angle measures 5 pi over 6 radians and the radius of the circle is 16 centimeters, round to the nearest tenth. So area is 1/2 R squared theta. So 1/2 16 squared times 5 pi over 6. So 0.5 times 16 squared times 5 pi over 6. And the calculator says the area is about 335.1 area, so centimeters squared in this case. That's finding the area. And I believe that's the last slide there.